Next, we'll talk about LED display and driver circuit. So LED is a diode which when forward biased emits light. So this is the representation of LED, where we have whenever the PN junction is forward biased, the electron crosses the PN junction from N-type material and recombine with holes in the P-type material. So the free electrons in the conduction band will be generally at higher potential with respect to holes in valence band. When recombination takes place, electron releases the energy in the form of heat and light. Normal diodes generally emit the energy in the form of heat, but LED emits the energy in the form of light. So this concept of working of diode already you have seen in your basic electronics. So the only difference is here, this is a special type of diode that emits energy in the form of light. So this is the LED driver circuit. We have the digital circuit, and on one end we have plus VCC 5 volts, and we have RS, and we have an LED connected here. And then output of the digital circuit is either high or low, that is 1 or 0. Logic 1 corresponds to plus 5 volts, logic 0 corresponds to 0 volts. So here, if the output of the digital circuit is plus 5 volts on both the sides of the LED, that is anode and cathode, it is at the same potential, therefore LED will not get forward biased. On the other hand, if the output of the digital circuit happens to be 0, there is a potential difference created, thereby current starts to flow and the LED will be forward biased and it glows. So this is how the LED works, and the application is 7-segment display. Next we go on with recording devices. So coming to the first one, it is strip chart recorder. So coming to the strip chart recorder, we have a range selector. See, coming to the recording devices, the measured values here will be recorded and can be stored for displaying later on. So in strip chart recorder, we have a range selector, signal conditioning block, we have a servo motor, and paper movement direction is shown here, and the markings that are done on the paper have been shown here. We have an event marker, chart drive, and chart speed selector, and this is the event input. So the range select, whenever the input is given to the range selector, it automatically adjusts the signal to the range required by the next block, and then signal conditioning, either it will amplify or attenuate the signal, that is increase or decrease the amplitude, and feeds it to the signal conditioning block. Signal conditioning block, it feeds to the servo motor. Servo motor basically drives this particular pen on the paper. Paper also tends to move. And then there is a chart speed selector and chart drive that drives the chart on the, that is nothing but the paper or chart will also be driven by a motor, and the speed of its movement will be controlled by chart speed selector, and then the movement of the pen will be controlled by this servo motor. So the movement of this pen will depend upon the input signal. Input signal drives the servo motor. Servo motor moves on the sheet according to the input signal. And then it is called as ink pen mechanism, where the marking mechanism, there are different types. So before that, we'll discuss about the paper drive system. Long roll of paper generally moves vertically, and the movement is driven by a motor, and its speed can be controlled. Now coming to the marking mechanism, we have pen and ink type mechanism, where ball pen or fountain pen or V pen is used. The tips must not be sharp because it may tear the paper, and ink usually is red in color. Advantages: it is not expensive, wide range of speeds with the switch can be obtained, friction is less. The drawback is ink spillage may happen when the movement is at high speed. Then the clog at the stylus rest, which may cause blotting of paper. That is, there may be, when there is a blockage of the ink at the tip of the pen at the nib point, there may be a blotting. These are the drawbacks of pen and ink mechanism. Next one is heated stylus type. Stylus is nothing but the liquid part or the ink part of it. Generally that is made of wax here, and when the wax melts, whenever it is heated, and it is the melted wax is made to fall on the black paper. So here the ink mechanism is replaced by wax, and the heating is done based on the signal. This is costly but highly reliable, and there is high contrast since wax is white in color and then paper is black in color. Next, other type of mechanism is impact printing, where pressure sensitive paper is used. V-shaped pointer of the pen is passed under the chopper bar, which presses the pointer onto the paper, and impact is transferred on the paper. That is, on the unknown signal is fed to the V-shaped pointer of the pen, and then it makes an impact. Whenever the signal is applied, it makes an impact on the pressure sensitive paper, and the pressure sensitive paper records the variation of the signal. This method is quite slow. Then we have electric stylus. Special electrosensitive paper will be used here. Current will act as a stylus, and traces are obtained on the paper. Paper which is sensitive to current is used as the recording material. Then we have electrostatic stylus. Electrosensitive paper is used. High voltage discharge on paper which leaves permanent trace on paper. This is a very rare method. Then we have latest one, which is optical marking, where a photosensitive paper is used as the recording chart or material. Beam of light acts as marker. Then the advantages are it is fast, it has got good resolution, and then it is expensive. The demerits, it must be developed to visualize, which is a time consuming event. Then comes the tracing system. So first we have seen paper drive system, then we have seen marking mechanism, now we say tracing system, curvilinear chart, and then rectilinear chart. The x-axis line is curved in shape, and the stylus moves in arc type. This is curvilinear system. In rectilinear system, the x-axis is a straight line similar to any other graph. Then the next one is galvanometer type recorder. So this is the arrangement of galvanometer type recorder. We have a permanent magnet here, and then a coil and former wound on a former, and here we have an ink reservoir which stores the ink, and we have the pen over here that drives on the paper. So we have rollers that basically drive the paper in one direction, and there is a corresponding motor for the same. Pen will basically move on this paper to record the signal, and we have an hairspring here that will provide the damping. So let us see the same here. Consists of coil and former placed between magnets, spindle pivoted on the shaft, and ink reservoir pen system is attached. Pen is mounted on sheet of paper which rolls as usual. Sheet or chart is curvilinear type, where x-axis is in curve, and it works on the basic D'Arsonval principle, that is, current carrying conductor placed under the magnetic field experiences a force. So here the coil is made to carry the current. So whenever current carrying conductor is placed in magnetic field, it experiences a force. And this tends to rotate, or it tends to move, and that movement is transferred by the pen on the paper. So the unknown signal in the form of current will be fed to the coil here, and the same in the form of movement will appear on the paper here. The pen also moves because of the force experienced by this common shaft, and the recording takes place on the paper due to the movement of the pen. So we can also use a transducer here which converts the physical quantity into electrical signal that can be fed to the current carrying coil. So this finishes with galvanometer type recorder. Let us see some more devices in the next session.